Alright, so the third type of transformation that we encounter is called a rotation, where you rotate something by a certain angle. Now, in later years you will learn some more advanced rotations, but all I'm going to teach you now is the basic ones, which is 90 degree clockwise or 90 degree anti-clockwise or just 180 degrees, not the special angle ones. Leave that for other years. So here we go. I'm going to say I need to do a rotation, and it's going to be of 90 degrees. Let's say, well, this is the first one. First thing I'm going to do is 90 degrees, so there's my point, 3, 5, and I'm going to rotate it 90 degrees in a clockwise direction. So 90 degrees clockwise. Sorry, that's my... Oh, let's take that away. 90 degrees clockwise. Alright? So, 90 degrees clockwise, which means that point rotates at 90 degrees about the origin. I have to say all my rotations are about the origin. Alright? Rotation of 90 degrees about the origin. And what I end up with is that my input, my x, y, this one's a little more difficult, and when you draw here, this is accurate drawings will help you here. So my point 3, 5, if you had done this and measured that and marked it off, you will see that the point 3, 5, they actually swap around, becomes 5 and 3, but wait for it. This is the negative side for the y, so it becomes 5 and negative 3. So they swap around and the y value becomes the opposite of what it was. So 3, 5 becomes 5, negative 3. As you can see, x and y swap around. So x becomes y, y becomes x. And what happens? The second coordinate, that one, becomes negative. See, that's my general rule for a rotation of 90 degrees clockwise. Alright. So, next one. Number 2. 90 degrees anti-clockwise about origin. Right. 90 degrees anti-clockwise. Now that means going in this direction. So I end up over there at a point 90 degrees this way. 3, 5, they swap around again. 5, 3, but in this case that's the positive x side, this is the negative x side. See that? So my point x, y input has simply swapped around again, y, x, but in this case the first coordinate became the opposite side of what it was. So I'm going to write my point there, 3, 5 becomes negative 5, 3. That's that rule there. Now let's just do our last rotation. Moving it up a little. Rotation of taking the point, right, my Cartesian plane, x and y. And let's say I have the point 3 and 5, my example point that I'm using. Now that is rotated through 180 degrees about the origin, and I end up with a point down there which is equidistant or just as far from there as from there, and when you read off the value there you'll get negative 3 and -5. Right? That helps me to do the following. I can say rotation of 180 degrees about the origin, and also remember that if I go clockwise or I go anti-clockwise, I will end up at the same place. 180 degrees doesn't matter which direction. You don't have to say whether you're going clockwise or anti-clockwise. You will end up at the same spot. So, 180 degrees about the origin. What happens to my input values? I said that 3, 5, my example point, changed into, through an accurate sketch, I measured off and I saw -3, -5. Now, that's just some way to start, because once you learn these rules, then you don't have to do sketches to determine what happens. That goes with X, Y stays in their order, and they become both change their sign. Because all these rules that I've given you for rotations and reflections and all that, all the rules are unique. So if you can figure out what rule has been applied, then describing it is easy. Right? And also from the graphs you can also see what has happened. So that's just my rule for 180 degree rotation. Right, let's go to the next one.